Look around you. The height of every person in a city. The errors in a scientific measurement. The scores on a standardized test. These things seem random. But if you collect enough data, a hidden pattern emerges. Chaos collapses into order. This shape is the normal distribution, also known as the Gaussian distribution or the bell curve. Mathematically, this curve is defined by a probability density function. It looks complex, but it is driven by just two numbers. The first is the mean, represented by the Greek letter mu. The second is the standard deviation, represented by sigma. Let's look at the mean first. The mean is the center of gravity. It tells us where the peak of the curve sits. If the average height increases, the entire curve shifts to the right. If it decreases, it shifts to the left. The shape does not change. Only its location does. Now, let's look at the standard deviation. Sigma. This controls the spread. A small sigma means the data is tightly clustered around the mean. The curve becomes tall and narrow. A large sigma means the data is spread out. The curve becomes short and wide. But no matter the shape, the total area under the curve is always exactly 1. This leads us to the empirical rule, or the 68, 95, 99.7 rule. In any normal distribution, 68% of all data falls within one standard deviation of the mean. 95% falls within 2 standard deviations, and 99.7% falls within 3. This gives us a powerful way to predict the probability of future events. Why is this omnipresent? The central limit theorem tells us that when you add up many independent random factors, their sum tends toward this bell shape. It is nature's favorite pattern. From the stars in the galaxy to the noise in this microphone. Variability is not random. It is normal.